Ça va? Merci bien pour choisir cette conférence. Okay, now I can ruin the rest of the talk. I already got my first clap, so yeah, that's all the French are going to get out of me today. I'm sorry. That was the best I could do. So welcome to the business of bisecting. So a little bit about me. So I'm Pauline, as was just mentioned. I am from Amsterdam. I'm a software engineer, freelance on paper, but currently I'm working in civil aviation. I mostly talk about Git. I try to talk about other things, but people only want to hear about Git. So here we are. I was here a few years ago doing a different Git talk. Was anyone there for that by any chance? Oh, okay. There you go. One person, I think, right? Oh, 2, 3. Okay, nice. Okay. So for you, there might be a little bit of repetition from the end of the last talk, but this is a lot more about Bisect, of course, because we have to fill like 40 minutes. So I am a mom. My kid is actually here because Disneyland, obviously, I have to take her. So if you see a tiny Cinderella walking around later during lunch, that's mine. And that is my handle on Twitter right there. If after the talk you feel like, oh, my team could use more Git knowledge, I am building a Git course that is online, and it's not published yet, but the waitlist for that is in my bio, so you can subscribe to that if that's something that you think that would be useful. So, enough about me. Let's get to the business of bisecting. Why am I giving an entire talk about this? Because I love this feature. This is my favorite Git feature. I think it's absolutely magical, and a lot of people don't know about it. If they do know about it, it's kind of like a mystical being for them. So who have heard of Bisect here? Hands up. Okay, so a bunch of people, oh, keep your hands up. Keep your hands up if you know what it does. See, this is what I mean. About half of the people who've heard of Bisect don't really know what it does. So it's a little bit like one of those things that people talk about, like, oh, have you heard about Bisect? But then you end up not really using it because there's not that many good explanations about what it is. So before I explain to you what it is, in a way that everyone's going to understand, I promise, I want to point you towards this repo that you can clone. And it's like a little test repo, and I'm going to demo it later in this talk. You can try to follow along, but I think it'll be a little bit fast. But then you can try it later by yourself. All you need is Docker with the Compose plugin. Oh, actually, Docker and Docker Compose separately. And it has like a make file and stuff. It should be pretty easy to run for anyone, regardless of your operating system and things like that. Okay, so to get to the point of what Bisect actually does and is, I usually use an egg and a building. The ones who have seen a previous talk may recognize that. And so let's say someone gives you a basket of eggs and points towards a building and says, I want you to give me the first story from which you can drop these eggs and they'll break. So let's say these are very sturdy eggs and they won't break on the ground floor. And you have to test which is the point that they will break on first. So you could start at the ground floor, drop one, it doesn't break. So then you pick up the egg, you go up a flight of stairs, you drop it again. You go downstairs, you pick up the egg, you go up another story, and you just keep doing that until you get to the point where it breaks. And then you found the first floor that it broke. So that can take a really long time, especially if it's a very tall building. You know, potentially if you have like a 50-story building, you would have to walk 49 stairs to find the first floor that it breaks, right? So there's an easier way to do this, a faster, more efficient way, and that would be to start it in the middle and then drop the egg, and it doesn't break. And then you know that the first floor is going to break on is between there and the highest floor. So then you take the middle of that. I know the diagram isn't exactly the middle, but let's pretend that's the middle. So you take the middle of that, and then you see that there it does break. So then you know that the first point is between there and there, right? So you go in the middle of that, and then that's the last iteration that you're doing, the last floor that you have to test. And so that you know that that last one is the first floor that will break the egg. So this is what computer science people might know as a binary search. If we have any, I'm not one of those people, but anyone who's done computer science has probably been taught about binary search. And that is what git bisect does. So bisect stands for cut in half. So that's what it does with your commit history if you're trying to find a specific point in time. Clear? So now everyone knows what bisect does, right? So this is super handy, specifically when you're trying to find regressions in your code. So if you notice a bug, for instance, you have this beautiful homepage, and you have this banner there, and suddenly, you know, after a few months, you visit this page again, and you notice that the banner has come down, which is not what you want. So what you can do is you go in your commit history, and you try to kind of see, okay, look at the commit messages and see like, oh, maybe I can check out what this commit about styling is, or look at like this JavaScript one or a markup one or whatever, kind of deduce from the commit message which one it might have been. But from experience, I can tell you that that's usually not very accurate. And you think you'll save time, but you're actually not really saving time. And bisect will save you a lot of time. So this is what a bisect looks like. I've kind of diluted the CLI output a little bit so you can see what's going on a bit better. And then I'll show you what it looks like in real life. So you start a bisect by saying git bisect start. That will take you into the bisect. And then you give it a good point. So you say git bisect good, and then a commit ID in this case, or a commit hash. There's a few other notations that I'll show you as well. So you give it a good commit, and then you say git bisect bad, and as a default, it takes your head. So your current point on your branch, the end of your branch. So now you've given bisect a range to test between. So those building floors, right? You have a good state and a bad state, and somewhere in between, you want to find the point that made the bad state. So then once you've given it a good and a bad state, it will check out the commit in the middle, and then you can refresh the page. And then here you'll see that when you refresh the page on this commit, the banner is in the correct place. So then you tell git bisect, you tell it git bisect good, as in this commit is good. And then you refresh it again, because then it checks out the commit in the middle of that. And then you refresh again, and you'll see that it's a bad commit. So you say, oh, that's a bad commit. So you just keep kind of doing that until eventually it runs out of the iterations that it has to test. And it'll say, blah, 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 is the first bad commit. And then you can go and see what changed in that commit, and see how this behavior that you didn't want was introduced. To get out of the bisect, you then go git bisect reset. So I'll show you a little bit how that works. Is this big enough for you? Okay, so we'll go into this random repo. I just got my nails done. This is the first time I'm doing a live demo with long nails, so apologize in advance for any typos. So we're gonna go, there you go, git bisect start. And then I'm gonna go git bisect old this time, because you don't always have to test for good or bad. So there's two sets of terms you can use, good and bad, or old and new. So if you want to test for an old state versus a new state. So now we're gonna use a slightly different notation. So let's say this. So this notation means from the head, I go back 20 commits. So this is 20 commits ago, I want to say is the old state, and the new state is my head. And then I can't use git bisect bad. See, because then it'll say, oh, you're doing new and old now. So we're going to go git bisect new, and we'll do one old. And we'll do a couple more old and a couple more new. And you'll see that the CLI output is a bit fluffier than I showed you before, but you'll say it'll tell you how many iterations are still left, and it'll tell you what commit it's on now. So it says roughly 2 steps, roughly 1 step, because it depends on how you test the commits. There might be 1 step more or 1 step less, depending on what the input is. So roughly 0 steps, and then it'll say blah, blah, blah is the first new commit in this case, right? So if you would have used good and bad, it would have said bad commit. So then we're going to get out of this, git bisect reset, and it'll take you back to your head. So that's what bisect looks like in the most basic form. And again, you can bisect for anything. You don't have to bisect for regressions. You don't have to bisect for old and new. You can also, for instance, if your test suites slowed down suddenly, it used to take 30 seconds and now suddenly it's taking 5 minutes and you want to figure out when that happened, you can give it your own terms as well. So you can give it your own terms by going git bisect start, and then in the start command, you give it 2 flags, the term old with the term that you want to use and the term new with the term that you want to use. And if you forget which terms you were using in the bisect, you can go git bisect terms and it will show you which terms you're using. So important to note that the bisect still works exactly the same. It's just kind of a helpful tool for you to semantically make sense of what you're doing. Because sometimes when you're not testing for good or bad, but you're using those words, it can get a little bit confusing. Now let's say you've accidentally marked a commit incorrectly, because you'll see here, this banner is in the correct place, but I've set git bisect bad. And I'm thinking, oh, oops, that's not what I want. That can ruin your bisect, right? So you can go git bisect reset and start over, which would be fine if you haven't done a lot of commits. But if you're at the end of like a really long bisect, that can be pretty annoying. So when you're in a bisect, you can do the following. I will show you here. I'll show you another way to start the bisect, because you can also say, give it the good and bad state straight away. So I'm going to say the first argument to the command, to the start command, would be your bad state. So I'm going to say head is my bad state, and then head tilde. I'm going to say 30 is my good state. So I'm going to go git bisect good, git bisect bad, and I'll do another bad. But let's say this one is incorrect, and I've done like 20 tests before this, and I don't want to start all over. So what you can do is you can use, I'll just clear this, you can use a log. See, it has this bisect log with all the steps that you've done. And something nice that you can do is you can write that to a file, and then you can go git bisect replay. So you can do that while you're still in the bisect, or you can get out of the bisect and then start a new one and replay the log file. So you just give it the log file. Oh, wait, first before we do that, because now it has the bad entry in there, we have to take out the bad entry, sorry. So I'm going to take out the entry that we don't want. This just opens in a text file. So it'll be nano or vim or whatever you're using in your terminal. So I've just taken out that bad entry, and then we're going to replay it without that entry. Oh. And then you'll see, if we check now where we're at, you'll see that it only has the good and it doesn't have the previous bad. So now you can just keep going without the mistake that you made. So that's quite nifty if you have to do a lot of really long bisects. So something that makes it even more magical, as with anything, is automation, because now you've seen how to do a manual bisect, but of course, anything is better with automation. So the way you automate it is, instead of manually going git bisect good, git bisect bad, you give it a script, any sort of script that has an exit code. And the exit code 0 will be good. So bisect will mark whatever commit it's testing as good automatically if your script exits with 0. And any other value between 1 and 124, I believe, is bad. So you can also give it like specific exit codes if you want to kind of be able to log what type of failure it was or whatever. But so that will mark it as bad automatically. So for instance, if we go to, let me think where it was. Oh, it's 2 folders up. There you go. If we go here, let's check if I'm on the right branch. Yeah. So you'll notice here that the README is missing. And let's say I know that the README was still there 20 commits ago. I can just go out and go ahead and check that by checking out 20 commits ago. You'll see that the README is still there, right? So let's say I want to test when that commit was removed or when that file was removed. I can check out each and every commit, or I can run a manual bisect. But what I've done is I've actually created a little shell script, README exists, that just tests if the file exists. And if it does, it's going to exit with exit code 0. And if it doesn't, it's going to exit with exit code 1. So it's going to mark the commit good or bad based on that. And I've put it outside of the repo, because if you put it inside the repo and you start traveling in time, which is what bisect does, right? Then your script is not going to exist in the past. There is a way around that, but we'll get back to that later. It's quite a fun way. But for this demo, we're just going to go get bisect start. Head is bad, and head till the 20 is good. So we're going to start it, and instead of now doing ls and going, oh, it's there, so I'm going to say get bisect good, I'm going to go get bisect run and give it the README script. So you'll see here that there's like, good, bad, bad. And then it'll say, this is the first bad commit. And you'll see here that you can confirm that, because you'll see here that this README file was deleted. Actually here, delete mode, README. And then we still do have to manually get out of the reset. So that's where it gets really fun, right? Oh, I already showed you the script. Now, another type of script that works with exit code is tests. So you can do the same with tests. So let's say, you wrote a test in the past, and when you wrote it, it was green, but you don't have CI/CD set up for that project, or it didn't have to be 100% green or whatever. I don't know. And you want to introduce that, then it's, in those cases, for instance, it's really helpful to be able to take the test that failed and run that through bisect. And then you'll find exactly the commits that made the test fail. And you can go back to that commit, make the tests pass again, and you can just go one by one and fix all of those tests that you have to do to get your whole suite green again. So that's super nice. And that's where this little repo comes in. This is a really fun repo that I'm going to demo to you now. And everyone who wanted to have it has already QR coded it? I'm guessing, yeah. Okay, so this repo, again, has like a README with instructions. So you can, if this was a little bit information overload, you can go and read that and just kind of follow the steps and do that. So let's go there. Can you still hear me properly when I'm leaning over, by the way, to do that? Okay, good. Because now we're going to go to this one. So here I think I still have to spin it up. So I'm just spinning up the container now. And then, so this is a little application called Trogdor. Are there any Homestar Runner fans in the house? Probably not. It's a little bit ancient by now, and it's a little bit internet culture. But Trogdor is like a dragon man-like creature who goes and burns villages in the Middle Ages. Okay, I see one person nodding frantically, so okay, one person gets it. So we're gonna run the application, and you'll see that, okay, my cottage is burning, and then burnination completed. So this is what we want. This is how Trogdor is supposed to function. Now, let's say you've been developing, so first of all, let's see where we're at. So the let it burn commit, that's the state where we know it's stable, right? So let's say we're in the future a little bit. We've made a few more commits. I think it's called tests. Nope. Forget what the branch is called. One sec. Oh yeah. Oh, sometime in the future. That's where it's not supposed to be. Oh, I've already fixed the bug in that one. Okay, wait 1 second. Okay, there we go. So now we're sometime in the future. And now we're going to run the application. And we are not seeing any output, right? So that's not good. Now, what we can do with Bisect is, you'll spotted already that I had one little commit with test. So let's say I've written a regression test for this bug. So here it's going to fail. If I run the, ooh, nay. We're going to run make tests, and it's going to fail, okay? So the test, what it does is it's just, where did I put the tests again? Not here, obviously. Wait. Is it in, I forget what, I haven't done PHP in a very long time. So I think it's here, right? Yes, okay. There you go. So it's a very rudimentary test, but it just checks for CLI output. It checks if the burnination completed, it's done. It's not the most robust test, but it will work for now, right? So what I said before is that with Bisect, you're traveling in time, right? So if I start going back to the let it burn commit and say, oh, that's the good commit, and then give it that test, it's not going to exist in the past, right? But what we can do with Git is a really nice thing called interactive rebase. And we can actually, okay, that's a bit much. I think I'll give it less than that. So what we can do is we can actually cut and paste the commit line to move it back into the past. And it'll rewrite the history of your branch so that the test file is actually in the past. So let's take this test commit and put it here after the let it burn where we know that it's going to pass. So we can just blame the nails. So we can just double check here. Go check out this test commit. And this is where it should pass, right? Right, so it passes here. So, okay, good, all confirmed. So now we can start our bisect. So we can say git bisect starts, take the head as the bad point, and that commit ID that we just checked out as the good point. And then we can go git bisect, run, make test. And it'll run it super fast, and it'll give the first commit here. So now what you can actually do is, we're not going to do that here because I'm guessing there's going to be questions at the end. Is there anyone who thinks they might? Well, whatever. I think it's too, like, normally I would go into the commit and show you what broke, and then what you can do is, you know, you can take the test commit, actually, take it to the broken commit, and start fixing that commit until the test passes again. And then you can kind of amend to that test commit, amend the change to that test commit so that you have one little atomic commit with the regression tests and the bug fix, and then you can create a PR out of that. So that's really nice because this is oh, I think we're still in the bisect, right? Yeah. And that's super nice because now you don't have to debug yourself. You can write the regression test, let the regression test and bisect debug for you any sort of unexpected behavior in production, and then you've immediately debugged, fixed, and written a test, and saved yourself a lot of trouble trying to debug and fix everything. So this is like the most magical part, I think, for Bisect. The fact that it's not just about finding a certain point in time, but it's actually, when you combine the power of multiple Git features, you can really let it just debug and debug for you automatically. So what happens is, oh, wait, let me go back. Because just here now, with this example, we ran one single test, right? So the scope is very small. And that's what generally I would advise you to do, is to keep the scope of the Bisect very small. Because as soon as you start running an entire integration test suite, for instance, not only is that going to make the run a little bit longer, which probably isn't too big of a deal, but more importantly, there's going to be more odds of one commit being untestable for a completely different reason. For instance, the dependencies 10 commits ago were different. So then, you have to run Docker or Composer install for that to work, or a completely different test was broken, or like a migration failed, or whatever. For some reason, this commit will fail, but not fail in the way that you're testing. It's not your test that was failing, right? So in those cases where your commit is untestable, there is a way around it, but you are complicating things a little bit more. So again, I would advise to keep the scope a little bit small. But if you can't do that, and you do know that there will be some commits that are untestable, there is a command, git bisect skip. So if in your manual bisect, you land on a commit, and you notice, for instance, with that page refresh from before, you notice that the whole page won't load, then you're like, okay, well, this one is not testable. Because maybe this is the commit where that banner moved down, but I'm not able to tell because I can't load the page, right? So in those cases, you can use git bisect skip, and then bisect will take the adjacent commit and lets you test that and see if that's testable. And if not, you can skip it again. Let's see if oh yeah. I'll just demo this really quickly with a range, because we're going to say git bisect starts and git bisect bed head 2020. That's my go-to, git bisect bad. Let's, oh wait, I did it wrong. Because that was supposed to be good. So git bisect good head tilde 20. And that's actually, for funsies, say git bisect bad is not our head, but like head tilde 2. So now we have a different range, right? We have 2 commits ago until 20 commits ago. So now what we can do is we can either say like, oh, this specific commit is untestable, so I'm going to go git bisect skip, or I'm going to go give it a range. So I'll go git bisect skip, and then let's say the range is like from here to here. It's these 3 commits that I want to skip, and then like good git bisect bad, and then you'll see here, if you git bisect log, you'll see that, like, you'll see all the commits that I marked, but you'll see a couple that say skip. So I've skipped those. So that's how skip works. You can give it a range or just one single commit. But if you give it a range, or if you skip multiple commits, there is one caveat, namely that if the adjacent commit to one that you skipped turns out to be the bad one, then Git won't be able to tell you if it was that commit that introduced the change that you're testing for, or the one that you skipped. And so if you have like 3 or 5 skipped commits, then odds are that you're increasing the odds that one of the adjacent commits is going to be marked as bad. And Git will tell you, like, hey, this one was the first bad commit, but it wasn't adjacent to ones that you skipped. So now you have to manually go and check those commits yourself, because I can't tell you. So that's just kind of another reason to keep the scope a little bit small, because the more you skip, the more likely it is that you'll have to kind of manually check out commits, and Bisect won't be able to find it for you. So, of course, that was a manual skip, but how do you do this with automation? Well, I did say that there was 0 to 124 was bad. There's one special exit code, 125, that will be auto skip. So here I've made a little script to demo that. So it's just going to take the same readme exists script, but before it does that, it's going to randomly skip a commit. So we'll go back to this one. We'll do the same exact thing. Head and head tilde 20. But instead of doing the readme exists one, we're gonna do the, I can't actually remember what it's called. Run, I think it's just called skip, yeah. So you'll see that it's, okay, it didn't actually do any skips. That's the problem with that. So let's try and do that again. Yeah, so there's one untestable commit here. And if you're super lucky, you'll get the, which is not in this case, you'll get the adjacent commit being the bad one. So sometimes that happens. I wonder if I can run it again, actually, and it just, no, I don't think that's the case. Well, anyway, it will tell you, like, okay, it's not accurate. You'll have to go in and test it yourself. So that's how you skip automatically, which is really great if, for instance, you want to run composer install, but like, you know, composer install fails for some reason. You can go like composer install or exit 125 if it fails. And then it'll just automatically skip that. And then you can always look at git bisect log after to see how many things were skipped if you need to. Also, what you can do in like a little bisect script like this, you can run your build, run migrations, things like that. You can even, instead of skipping, you can fail something, and then if it fails, you can apply a patch, for instance, before you then continue with the test. And then you clean up that patch before you mark it good or bad. And then, you know, it cleans up the patch before you go to the next commit, and so on. So if you know what's going to make the commit untestable, you can apply a patch for it before every test and clean it up. So there's lots of things you can do with this bisect script if you have to, if you can't keep the scope very small. So in conclusion, before you go to questions, I think we still have like 5 to 10 minutes for questions. Try to keep the scope small. So don't run your entire test suite, migrations and things like that. Try to keep it to like one test or one script. Use atomic commits. So I haven't really talked about atomic commits, but basically all of what I teach Git is based on this foundation of atomic commits. It means they're very small commits, very small kind of units of work. You just organize your commits in a way that they're very small units of work. Why? Because if you have massive commits, then Bisect can find a given commit for you, but then you're still digging through lots of changes, right? If you use very small commits for everything, then Bisect will point you to exactly the commit you need, and it will just be like a very small set of changes that you have to manually sift through. And also, atomic commits, one feature of atomic commits is that they capture your application in a stable state, so you're also less likely to run into untestable commits on your Bisect. So really useful. Atomic commits make pretty much every Git feature more useful. So definitely look into that if you want to try and do Bisect. And lastly, if you can't keep the scope small, write a Bisect script to handle everything that you need to do. But yeah, avoid it if you can, because nobody wants to write more scripts than they need to. Thank you. If you have any questions, let me know.
Do you have some questions? Yeah.
Thank you very much for this talk. I have a question about nonlinear history. If you have, for example, a feature branch that you merge into master, so you have two branches maybe between the good point and bad point. Mm-hmm. How does Git handle this case? Does it switch over two branches? Or?
No, you just do it on the one branch. So I'm guessing you're thinking of like a squash merge situation, right? Where you have like one big merge commits.
Yeah, this kind of thing.
Okay. So yeah, that's also a lot of people ask me like, because I'm really pro atomic commits and even keeping them atomic when you merge them into your main branch, for really only because of Bisect, because then you can still use. So what I would suggest most of the time is if you, for cases when you want to test your main branch, you want to try to fast forward merge or fast forward rebase everything on your, use that as your merge strategy, because then you will keep all the commits from your branch And because you're always just testing on one branch, basically. So if you have any other questions, you can always DM me on Twitter or around. So
Thank you, Pauline.
thank you.